Welcome back to Easy Chemistry by Venla. Today our topic is reactive intermediates. So in this reactive intermediate, fourth one is carbene. I already explained carbocation, carbanion, free radical in previous videos. Please check it once. So in carbene, imagine a character. He has no stable home, no proper bonding. He lives only for few seconds. But in those few seconds, he can completely change another molecule. That character is called carbene. Today, we are not just learning a concept. We are watching a concept like story. So, in this part 1 is what is carbene? Let's enter the story. This is a carbon atom, but something is wrong. Carbon has only two bonds and two electrons left alone. It is neutral atom and 6 electrons. Carbon should have 8 electrons, but here carbene has 6 electrons. So that is why it is called as electron deficient species. Because of this, it is highly unstable. Highly unstable. It reacts immediately. So it is like an angry character. For example, think like this. If a person who has incomplete work, no support system, it needs something urgently. He will act fast and random. Same like carbene. Next, structure and types of carbene. Now, carbene has two personalities. So, carbene is two types. One is singlet. Another one is triplet. Singlet means here both electrons together like best friends. It is slightly calm, controlled, intelligent. It reacts in a synchronized way. It has one lone pair. sp2 hybridization and it is bend shape molecule. So what is the bond angle? 103 degrees. It is like a hero who planned everything. Next, triplet carbene. Here, two electrons are separate. These two electrons are separate. It is aggressive nature, radical behavior, act step by step. It has two unpaired electron. Two unpaired electrons. This is sp hybridization. It is also bend shape molecule. So bond angle is 136 degrees. It is like a villain who attacks randomly. This is like villain who attacks randomly. This is like hero. It plans everything. For example, same character but depending on situation. He becomes hero or villain? Give answer in the comment section. Next, stability. Triplet carbene is greater than singlet carbene. Sometimes aggressive ones survive longer. Next, part 3. Generation. Generation of carbene. Carbene is not born normally. It is created. So in this method one is first one halo form. Chloroform CHCl3 reaction with base to form carbene CCl2 and HCl. This is like a powerful explosion create carbene. This is carbene. Next one is photolysis or heat. It gives energy, bond break. Carbene appears instantly like a sudden entry in movie. For example, like a gamer spawning suddenly in battlefield. No background, directly action. Here, diazomethane. Diazomethane in presence of light, it form carbene N2. Next, ketene. Ketene also it forms carbene CH2 plus CO. Here bond break like this. Diazoketone. This is diazoketone. Triple bond H nu heat Ag2O that forms acyl carbene. This is acyl carbene. Finally, it forms ketene. This is ketene. It is acyl carbene. Diazoketone. Diazoketone reaction with heat thermal in presence of Ag2O, it forms acyl carbene and ketene. This is one rearrangement reaction. What is that rearrangement reaction? This is Wolff rearrangement. Wolff rearrangement. Next, aryl sulfonyl hydrazone. This is aryl sulfonyl hydrazone. In presence of H nu, it forms carbene. This is carbene. Next, same reagent. This is also carbene. Whenever molecule is break, carbene is born. Next, stability of carbene. Now the question is, if carbene is so unstable, is there any way to compare which one is more stable? Singlet versus triplet stability. Here it comes a twist in the story. In most cases, triplet carbene is more stable. Why? Because of electrons are separated, less repulsion. For example, think like this. If two people in a same room, more conflict. Two people in different room, it is peaceful. Same concept. Sometimes singlet becomes stable whenever electron donating groups present. It depends on substituent effect stability. So I am giving one example. What is the stability order here? Even in chemistry, surroundings decide stability. So here correct order is 3 is greater than 1 is greater than 2. Then you can clearly understand electron deficient stabilized by electron releasing group and plus mesomeric effect groups. Detection. Next one is detection. Now biggest mystery here. Carbene lives for short time. Very short. Carbene lives in very short time. So how to decide scientists even know how it exists? Scientists don't see the carbene directly. They can trap it by using reactions. For example here, carbene reaction with alkene. It forms cyclopropane. So if cyclopropane is formed, carbene was definitely present. Like catching a criminal. You don't see the crime, but you see the evidence. Same way, carbene is invisible, but its reactions reveal its presence. Next one is chemical reactions. So, in this first one is cycloaddition. Here also alkene reaction with carbene. In presence of H nu thermal, it forms cyclopropane. This is the most powerful reaction of carbene. What happens? carbene reaction with alkene. It forms cyclopropane ring, that is the three-membered ring. Carbene add across double bond. Carbene will add across double bond. Both bonds formed simultaneously. These both bonds formed simultaneously. It is singlet carbene. Difference based on types. If it is singlet carbene, one is singlet, another one is triplet. Singlet carbene is concentrated reaction stereospecific. This is concentrated reaction stereospecific. This is stepwise reaction. Non-stereospecific. For example, two styles of attack. Singlet, smart hero, finishes fight in one move. Triplet, it is wild fighter, take multiple steps. Another example for Gen Z students, like in games. Singlet, one shot kill. Triplet, multiple attacks. This reaction is so important that it is used in real chemical synthesis. Next, finally, reactions. Addition to double bond. This is most important. Alkene reaction with carbene. Carbene reaction with alkene. It forms cyclopropane because carbene wants stability. Carbene wants stability. Fast. Carbene wants stability in fast. For hero sees unstable situation. Immediately then fix it. Then who is hero here? Carbene. Carbene is the hero now. That is cyclopropane formation. Now singlet versus triplet reactions. First one, singlet. It is a clean reaction. Direct stereospecific reaction. Thermal, it forms like this. Here cis is there, so here also cis. Cis is there, it is cis. If it is trans, then it is trans because it is stereospecific concentrated reaction. Next, triplet. Already we know this is non-concentrated, non-stereospecific reaction. This is step-by-step messy reaction. It gives mixture. Total unpredictable. This is cis form and another form is trans form. Here trans is greater than cis. Next, insertion reactions. Insertion reaction. Carbene can insert in CH bond. It forms like entering between two friends and changing their bond. Next, rearrangements. Rearrangement reaction. Because it is unstable, it rearrange or react differently. Like unpredictable characters in movies. It reaction with diisomethane. Next, it forms again it reaction with H nu thermal Ag2O. It forms ketene. I already told in this reaction. What is the reaction? Wolff rearrangement. Okay. This is ketene. Again it reaction with water. It forms carboxylic acids. What is this rearrangement? On ester rearrangement. on a step rearrangement. It can changing the structure completely. Next, some special reactions. So in this, first one is Siemens-Smith reaction. What is the Siemens-Smith reaction? Cycloalkene can form into cyclopropane. Cyclopropane. This is the reaction. Diiodomethane and copper zinc. It forms like this. This is the cyclopropane. Second reaction is Riemann-Tamer reaction. Phenol in the presence of CHCl3 and NaOH, it forms aldehyde. One is ortho and another one is para. Next reaction is ring expansion. This is pyrrole. It reaction with CHCl3 NaOH. It forms 3-chloropyridine. So finally, properties. Carbene is neutral species. This is neutral species. It has 6 electrons only, highly reactive and short-lived. Basically for born, react and disappear. For example, some characters don't live long, but their impact stay forever. So finally, today we learn what is carbene and its types, singlets and triplet, generation, reaction, properties. Carbene may live only few seconds, but in chemistry, it plays a powerful role. That's the end of the carbene. That's it for today's video. I hope this explanation made the topic easy and simple to remember. If you found this video helpful, please like, share, comment and subscribe to Easy Chemistry by Venla. Thanks for watching. Keep learning. I will see you in the next video.